Okay, so here we have two functions that are being convolved together. X of t and h of t. H of t is this awful function right here. It's just a simple triangle, but you'll see it's still awful. This other function is what we're convolving with, the x of t, which is equal to u of t. We decided to flip and shift this one as it would be easier than trying to flip and shift the h of t. And since we know that the convolution property allows any order in which to convolve them, we're just going to use this method because it's easier. Alright, so first things first, until t reaches this front edge right here, it's 0. The convolution is equal to 0. So we have t less than 0, y of t equals 0. Okay, now as this front edge right here starts moving towards this part, so it goes 2, 1, it's being convolved with this equation right here, which is going to be 2 tau. Okay, so now we have y of t equal to the integral, since we know the convolution is defined as integral from negative infinity to infinity, x of tau, hold on, my bad, h of t minus tau, d tau. Okay, so now we have this integral being set up, and it's from 0 to t, 2 tau, d tau, which, when you solve it, it's equal to t squared. Okay, now that we have that, we are going to consider the next section, which will be as it's passing 1. Okay, so we have, well, first let's put our bounds here, 0 less than t less than 1. Such that, what is that? Okay, so now we have our third epoch, or whatever you really want to call it, where we have 1, t, it's not equal, my bad, 2, such that y of t is equal to the integral from 0 to 1 of 2 tau, because we're still including this first part. It's still in there. So d tau. It's still inside this triangle. So it's 2 tau d tau plus the integral from 1 to t as t moves along somewhere between 1 and 2. We have the equation minus 2 tau plus 4 d tau. Now when you solve that, you're going to get this equation out. 1 plus negative tau squared plus 4 tau evaluated from 1 to t, which is equal to 1 minus tau squared plus 4, or that's not tau, that's t, my bad, plus 1 minus 4. And as you can see, this is just belonging to that first section, and this is the full expression for the new section. So we get that this is equal to minus 2 minus t squared plus 4t. Alright, and this is for t less than 2. And now we're going to our last part as the equation, as the function x of t passes through h of t completely. And so the back end is following through, and we have 2 is less than equal to t. This is our bound. So we have that such that y of t is equal to the integral from 0 to 1 of 2 tau. Remember, that's the same equation as we've been using, d tau, plus integral 1 to 2 of minus 2 tau plus 4 d tau. As you can see, this will just give you a constant, and that constant is 2. And so there's no more dependency on tau or t, and so that concludes the convolution. So we can write y of t as a piecewise function that is 0 for t less than 0, t squared for 0 to t but less than 1, and then minus t squared plus 4t minus 2 for 1 less than equal to t but still not to 2. And then ending, we have 2 for pretty much all else time. And there you have it. That's convolution. Thank you, Georgia Tech.